Hello everyone, this is Vivian Chan. Today in this video, I'm going to explain it to you HSC 2018 Mathematics Extension 2, question number 1 to 3. Question 1, it is a multiple choice of integration, but this integration is tricky because what needs to be integrated is placed within a third sign. We have to think of some techniques to get rid of this third because if things are under a third, we cannot do the integration. Let's do some revision. We know that sine squared theta plus cosine squared theta should be equal to 1. And then if we transpose the sine squared theta to the left-hand side, we can have this 1 minus sine squared theta square root equal to cosine. Therefore, if we can do some substitution to change this 1 minus 4x squared into something similar to this, then after taking the square root, we can get rid of the third. But here the problem is, if we let x be sine theta, we still have this 4. It cannot be exactly 1 minus sine square theta. So we have to make it something like this, so that the 4 can be cancelled out and leave you 1 minus sine square theta square root equal to cosine. So we let x equal to sine theta over 2. And inside the third form, we have 1 minus 4x squared, which means 1 minus 4 sine theta over 2 whole thing square. And sine theta over 2 whole thing square would become sine squared theta over 4. The over 4 and the multiplication of 4 here, they cancel each other. And it gives you 1 minus sine squared theta after taking the square root. You will have only cosine theta left. Therefore, with the substitution we have here, we can get rid of this third form. So we know that root 1 minus 4x squared equals to cosine theta. How about dx? Because x equal to sine theta over 2, then dx d theta should be the 1 over 2 d sine theta should become cosine theta, which means dx should be equal to half cosine theta d theta. Everything's ready. Let's just do the substitution. The third become cosine. The dx become 1 over 2 cosine theta d theta. So the cosine and the cosine, they cancel each other. And eventually we are doing integration of 1 over 2 d theta, which means you have 1 over 2 theta plus c. And the theta, because the substitution is x equal to sine theta over 2, so theta would become arc sine 2x. So the answer is B. Question 2, it is a question about hyperbola. The question asks for asymptotes of hyperbola with this equation. First of all, let's do some revision on hyperbola. The standard equation of a hyperbola is like x squared over a squared minus y squared over b squared equal to 1. When y equal to 0, you will have x squared equals to a squared. And take the square root of x, you will have x equal to plus or minus a. So this a is actually talking about the vertex of this hyperbola. And then when x equal to 0, the minus y squared over b squared should be equal to 1. It is impossible because y squared over b squared is a positive number. Minus a positive number is a negative number. How can a negative number equal to 1, right? But if we just ignore the minus sign here, we know that y squared over b squared equals to 1, then y should be equal to plus or minus b. And if we draw a rectangle here passing all these 4 points, the diagonals of this rectangle will become the 2 asymptotes of this hyperbola. So what we know here is when x equal to 0, the parabola cannot pass through y equal to b or minus b because a negative number cannot be equal to a positive number. But this b, it gives you the equation of the asymptotes of this hyperbola. Because we know the coordinates of these vertices of a rectangle, and the asymptote pass through points minus a, b, and the origin. And therefore, the slope of this asymptote should be equal to minus b over a, and the equation of it is y equal to minus b over ax. Similar to the other asymptote which passes through points AB and the origin. The slope of it is b over a, and the equation is y equal to b over ax. So what we need to do with this question is we change the equation of the parabola into the standard form. The standard form right-hand side should be equal to 1, so we divide the whole equation by 36, and it becomes x squared over 4 minus y squared over 9. Then the equation of asymptote should be this one. The answer is C. Question 3. It is telling you that there is a cubic equation has roots alpha, beta, and gamma. The question asks you to form another cubic equation with roots minus 1 over alpha, minus 1 over beta, and minus 1 over gamma. And then we know that a cubic equation standard form ax cubed plus bx squared plus cx plus d equal to 0. Then sum of the three roots should be equal to minus b over a. Sum of the products of any two roots should be equal to c over a, because product of two, even number, so it's plus. Product of the three roots, three odd numbers, so minus, should be d over a. Therefore, it is not difficult for us to obtain this three equation. And this is a cubic equation with roots minus 1 over alpha, minus 1 over beta, or minus 1 over gamma. Expand this equation, you will get this one. Now we have to evaluate this coefficient, and this coefficient. This one is simple. From here, you know that it equals to 1. The coefficient of h squared should be 1 over alpha plus 1 over beta plus 1 over gamma. And to unify the denominator, you will have this. And from the three equations we obtained before, we know that the sum should be equal to 5. And the coefficient of x, again, we unify the denominator to become alpha, beta, gamma, and then we will have the denominator sum of alpha, beta, and gamma. Okay, from the three equations we obtained before, again, is minus 2. And therefore, the cubic equation should be this one. And the answer is D.